Hi everyone, welcome back. Today we're doing count items matching a rule in C++. This question is great for practicing two-dimensional vectors or arrays. So in this case, we're given an array items where each item vector in this case represents a vector of size 3. So the first item will represent the type of item, the second index will contain the color of the item, and the third index contains the name of the item. So in this case, we are given a rule represented by two strings, rule key and rule value. And the ith item, any item per se, is said to match a given rule if one of the following is true. If the rule key given to us is equals to type, and rule value is equals to the same rule value that we're given, and so on and so forth for the color and the name, then that item is said to be matched. So we have to return the number of items that match the given rule. Personally, I find that this way of phrasing the question is not that clear, so let's try to break it down a little bit more. So we have, in this case, 3 items, and the rule key given to us is color, and the rule value is silver. So what this means is we are filtering on the second index for every single item, and we are checking if each of the items are equals to silver. And if they are, we increment the count by 1. So in this case, we only have one item that is of silver color, so we return 1. For the second example, we are given 3 items similarly, and this time we are filtering by rule key equals to type. So type in this case is the first column. So we check through all the items, and in this case we match 2 items which are of type phone. So return 2. In this case, for each of the items given to us, they range from 1 item to 10 to the power of 4 items. And in this case, the length of the type, color, and name, as well as the rule value length, is from 1 to 10 characters. And rule key is either equals to type, color, or name. And finally, all strings consist of only lowercase characters. So the approach to tackle this is to get the index that we should look at for every single item with respect to the rule key. So what this means is if the rule key is equals to type, we would set the index to look for in every item to be 0. And this would match the first item in each of these items given to us. Then if they are color, then we return 1 as the index we'll be looking for. And finally, if it is the name, then we will look at the second index, like index 2, or rather the third column inside each item. So this would be pretty much a series of if-else statements. And once we're done, we will iterate through every single item, and we will use that rule key index to get the item. And we will compare each of these strings together with the rule value. So that's pretty much it. Let's get started. So we will first get the rule key index. This rule key index is for convenience, as we discussed earlier, and this indicates the index for every single item that we should look at. And if the rule key is equals to type, then in this case, rule key index will be equals to 0 because we are looking at the first item. Else, if the rule key is equals to color, this means we are looking at the second item. So rule key index is equals to 1, else rule key index is equals to 2. And that's pretty much it. So now that we get the rule key index, let's iterate through each of the items. So for string item, in items, we will use this rule key index to get the string that we should be comparing against for the rule value. So let's get the item value, and this will be equals to item at rule key index. And if the item value is equals to rule value, then we have just found the item. So let's define a count match. Count matches equals to 0. And if we match an item, we increment it by 1 over here and return the final result like this. after iterating through every single item. So let's try tracing this out with a simple test case and see if this implementation works. So let's do this. And let's take a look at the rule key and the rule value given to us as well. So rule key in this case is color. So what this means is this is the second item in every vector. So this would be silver. And we are pretty much looking for items that are silver in color. So in this case, because the rule key is equals to color, our rule key index will be equals to 1. And let's start tracing. So count matches will be equals to 0. And in this case, let's start looking at the first item over here. So item is now targeting a vector of size 3. Item value will be the second item in this case because it's index 1. And in this case, because blue is not equals to silver, we will skip this. Now we will take a look at the second item. This, in this case, is silver. So we will increment count matches by 1. For the final item, this is not silver. This is gold. So we will not do any incrementing over here. In summary, we will return count matches equals to 1. And that's pretty much it. So let's run this against some of the test cases. Okay, wow, okay, is it because I screwed up here or? Oh yes, of course, the type given to this is incorrect. This is supposed to be a vector of strings. So let's run this again. Okay, this passes and let's submit this. And there we go. So in this case, if we let n to be the number of items, in this case, the check for the rule keys in this case would not scale. So this is O1 with respect to n. And in this case, all of these operations are O1. This is where it scales with On. We will be iterating through every single item. So understandably, if we have more items, we'll have to do more check over here. So in this case, it's going to be On. Each of the operations under each iteration is O1, so that's pretty much okay. So in summary, the time complexity for this algorithm is On. Now let's take a look at the space complexity. So we use a constant amount of memory over here, 4 bytes for this integer over here, another 4 bytes over here, but this is pretty much O1. This doesn't scale. The memory used by this variable doesn't scale with respect to n. In this case, we use a constant variable here to keep track of every item. So this is O1 as well. And this string over here is reused. So this O1 as well. So in summary, the space complexity is O1. So that's pretty much it for this question. If you find this useful, please give us a like and subscribe, and we will see you in the next video.